We're going to start with this and then your questions. So number one, we go through the previous notes. Number two, we do the concept puzzle from last class. And number three, I answer any questions you want, and then we move on. Question number one, or statement number one. The branches of a piecewise defined function can or cannot overlap. I don't hear anything.
Cannot.
Absolutely. If they do, there will be a tragedy because this will not be a function. Awesome. Thank you so much. When asked to graph a function, the is determined first.
Domain.
Thank you. A secant line through a graph of a function crosses or touches the graph.
Crosses.
Very good. The difference quotient is, can anyone give us the formula? This has to be learned by heart. I know my tests and the final exam are open notes, open book, but if you need to look up each and every item, you will not be able to finish.
The function equals. Go ahead.
F of x plus h close parentheses minus f of x divided by h.
Very good. Awesome. So this is it. Sorry, I meant to write it in a different color, but okay. The limit operator is or is not the same concept with a function value at that point.
Say
Say it again.
same concept.
Okay.
Is not.
Is not. So that's why I still keep this here. Before I put it in. So the limit is asking for a trend, not specifically not the function value. So this concept applied to f of x is not the same with this concept applied to 2. Good, moving on. A limit of a function exists only if it is a
Real number?
Oh, yeah. Number.
good, awesome. Correct, real number, correct. The options for a number over 0 are
Negative and positive infinity and any.
very good, awesome, thank you. 0 over 0 is an,
Indeterminate number.
careful, one more time,
Indeterminate number.
careful.
Case.
Undefined.
No. So a number over 0 is undefined.
Indeterminate?
Yes.
What was I saying? I thought I was saying.
Yes. I said both. I said to you, yes, and to your colleague also, yes. Yes, I know you said that. Good, awesome. Now the floor is open for your questions. Anything from anything. Let me double check that I still have the book open here. I worked with a student from another class earlier, and I don't know if I'm logged out or not. I hope I'm not logged out. Yes, yes, I'm ready.
Can we go over like the homework one with the piecewise?
Yes.
Okay.
Yes. So I'm hoping that this will help. And again, I will always answer any questions, but I'm hoping that moving forward, we have this down and clear. Good. So I'm opening. I'm going to share my screen and go to our class. As I said, sorry, I see those 3 messages, but I can't answer. I can't look at that right now. Okay. So the problem is right here. Let's copy it. Now, also remember after class, these solutions will be posted as well. So what I'm saying is, unless it's absolutely necessary, which is fine by me, you will have solutions posted after class. So if it's not absolutely necessary to ask in class, that's, you know, you have it. But again, it's up to you. I'll answer any question anytime. Good. So first of all, we identify what?
The domain.
Absolutely. So can anyone change these into interval notations?
The first one is parentheses negative infinity to comma -1 close bracket.
Excellent. Close or bracket is the same. Very good. Awesome. This one?
Is it parentheses -1 to 2 close bracket?
Very good. And for this one?
Parentheses 2 comma infinity.
Good. Now, can anyone identify the domain for us? Yes, absolutely. It happens that -1 is here, but not here. 2 is here, but not here. So we have negative infinity to infinity. These are the extremely important x values. They have to be there. 0 has to be in the table at all times. Even if the function is undefined at 0, 0 has to be in the table. Unless, I shouldn't say always, unless we have a domain like 2 to 4. Of course, if the domain is given to us 2 to 4, of course, 0 will not be in the table. But if the domain is like this, 0 has to be in the table. Okay, so I'll copy the brackets exactly under -1, not skewed to the left or to the right. And the same thing here, 2 facing left and open parenthesis, the bracket facing left and the open parenthesis facing right, as we did last time. So the first one will be indeed the cube root of x, the next one will be x, and the next one is x minus 1 squared. Now we have to plug in values. Stop me if you have questions. Again, this is not a monologue. Okay, so in the cube root, when I plug in -1, I get -1, and I write it right inside the bracket. Why I write it inside the bracket? Because I know that this is what type of point now? Full or open?
Closed.
Yes, full or closed.
I have a question. So in the last video, you had set the problem equal to 0. So you only do that. When do you set it equal to 0?
When I find the x and y intercepts. But in this particular case, the cube root of x, so I can't have anything here that it's x and y intercept, because the cube root of x will be 0 when x is 0, and 0 is not in this interval. Very good point.
Oh, so you don't have to do it for each of them?
And as long as it exists in that interval, I have to. But if it doesn't exist in that, yes, good point. Good point. Thank you. Thank you for asking. Very good question. So I'm going to put in -8 because the cube root of -8 is nice and easy. What is it? Right. Indeed, -2. Good. We're done with the first branch. Now I plug in -1 here, and it happens that I get -1. I plug in 0, I get 0. I plug in 2, and I get 2. Now I plug in 2 here, and 2 minus 1 squared will be 1. I will also plug in 3, and 3 minus 1 will be 2. 2 squared will be 4. That's all I need. And of course, I should have asked what type of point is -1, -1. You would say it's open, but since these two values are the same, it will end up being a full point. What about 2, 2? This will be a full point, but 2, 1 will not. So this will be open. Good. So that, as I said, that's all we need. Again, I will be using 3 different colors, not because I'm asking you to use 3 different colors, but because I need to make a point. Okay, if those colors will overlap again, and they will, for some reason, I don't know why, then the graph is incorrect. So -8, -2. Maybe if I say that, maybe this is not going to happen. So let me use this. If any of these colors it's not visible, please stop me using it. So -1, -1 is a full point. And if you have to remember, the cube root looks like this. But I can only graph this portion. Done. Away. Now, -1, -1 will start here because the values are the same. This is a linear function. Y = x looks like this. But I can only graph between -1 and 2. So at 2 is 2, and it's a full point, and it passes through 0, of course. And this is the second one. Done. And now, say it louder.
Oh yeah, well, that second point that you put on it, which is open, normally doesn't it surround the other point?
It's the same point. There's only one point.
Yeah, there's only one point.
So we don't have one here and one here. No, it's the same point.
You don't want us to do that?
No, there is no need. This is not correct. We don't do that.
Okay.
And then 2, 1, it's this point, and it has to be an open point. And then 3, 4. Okay, so the function, we know how to graph. This is a quadratic function that will have the vertex at 1, but I can't do that. I can't graph this. I can only graph this piece. So this is the graph of the function f of x. Can anyone identify the range if we need to for this function?
The range is negative, parentheses, negative infinity, and comma, positive infinity.
Excellent.
Close parentheses.
No, only open. Yeah, perfect. So that's it. Anything else? Other questions?
No, that was all. I was just confused about the points in the middle, but I did the same thing.
Good, awesome, good. Anything else? Do we have other questions from anything else before we continue with R.2.3? Another class is in R.3 now. I'm thinking of R.3. So, any questions? Anything from web? Yes.
So when we do our assignments, do we? So one thing I did was doing on it is I just did the graph to represent it, and before I didn't put the line graph up there. Do you want us to put the line graph up there?
By the line graph, you mean? I'm not sure what you mean by.
Okay, at the top you did. I figured out all the different points and everything.
The table is mandatory.
The table up there. Okay, got it.
Always.
When I did it without.
That's okay. That's why we're here. We're learning. That's fine. Just missing it right now for the skills assessment, it's okay. But moving forward, the table is mandatory always. You get a lot of partial credit if the table is correct and you just transfer this incorrectly here. Somehow it can happen, right? So I had 2, 2. Maybe I presented as 2, 3 by mistake. But if I have it here, I will get full credit. Good. Other questions from anything else? Okay. In that case, let's continue. Let me see. Every now and then I have to look at the video, see if it's close to 20 minutes, and then change it. So 2.3. I mean, move on to the next one. 2.3, limit laws. We have a ton of limit laws. No, I'm exaggerating. We have many limit laws, 11, 12 of them, something like that, and some theorems on how to determine the limits. And in addition to that, we have a theorem. So the limit laws plus the squeeze theorem. Okay. If you remember something and you want to stop me in the middle, you can. Again, this is not a monologue. I should find a better place to put that cup of water. Okay. So first of all, I would like to start with two theorems before we look at limit laws. So when we calculate the limit as x approaches a from a polynomial, any degree, I'm going to call this polynomial f of x. The answer is f of a. Although we specifically say x does not equal a, we will be able to determine every time we apply the limit to any polynomial f of x by simply plugging in it will give us the limit. That's the first theorem. Second one is identical limit of any other function as x approaches a, like rational, radical, trig, and so on and so forth. The limit of any of these will be, and I'm going to denote them again by f of x, will be f of a, but there is a catch here for these functions. Only if a is in the domain of f of x. If it is not, then the answer cannot be determined like this. Okay? If it is not. Why didn't I say this here? Because we all know that the domain of any polynomial function is, can anyone give us the domain of any polynomial function?
All real numbers.
Yes. So that's why here there was no if. So this will always be the case. Okay? So if a polynomial is defined on all real numbers, we never have any headaches. Nothing to worry about, in other words. But the limit of a rational, no. If a is not in the domain, I cannot do this. The limit of a radical, if a is not in here, then I cannot do that. And the same thing for the trig functions and any other function, basically. Good. So now we move on to, I'm going to list the limit laws in addition to what we just looked at. And then we're going to apply the limit laws. And then I don't want to forget, please remind me if I do, I want to show the difference quotient for different functions, like for radical, for rational, and polynomial. Okay? We decided to do this first, but since I started, I'm going to continue. So then we will go back to that. So let's list the limit laws. And as I said, there is a long list. So first of all, we have to assume. So without this assumption, the limit laws are not applicable. We are assuming that we have two functions, f of x and g of x. We are also assuming that the limit of f of x as x approaches a, from either side, from left or right, it doesn't matter, exists, is a number L, a number. And we will also assume that the limit as x approaches a from g of x is also a number. And not L, of course. It can be the same, but I meant to write M. Okay, so that's another number, or it can be the same. It doesn't matter. But for now, let's look at the general case. See, that's why I have my whiteout handy. So it's another number. Good. So with this assumption, and again, we have to check the assumption. We always have to check the assumption before we use a limit law. Okay? If the assumption is invalid, if the two functions don't have a limit